You guys have any questions? Did you try the homework and have problems on the homework? Please don't wait to start on this. It's going to snowball on you. You don't want to be up all night trying to figure it out. So right now you're equipped to do these 3 sections worth of homework. And so you'll see that there's a lot of problems in each. So with this one particular first one, there are only 8 problems. The second one, we have 15 problems. And with the third one here, the last section that we covered, section 2.1 in the yellow textbook, there's 8. So already there's 31 problems that you're basically able to do now before we move on to the next material. So I like for this first 10 to 15 minutes of every class to be you asking questions about the homework. Yes?
In the homework, that's like 2-1.
Mm-hmm.
It was number 5, or 15.
Okay. Let's take a look at it. Your numbers might be different, but did it look something like that?
Yeah, it was that, but it was different numbers. It was like x over 6 minus x over 2 equals 4. And
Right.
like the watch it thing, like it didn't really explain it at all. Just said to multiply each by 10, and I have no idea why.
Okay. Let's do it with your numbers. Let's go to the smart board and work it out with your numbers. I'll put down which problem it is so that when other people try to go do it with different numbers, they can refer to this. I tried to find a microphone to project to my microphone. That wasn't working out. So I just have to talk louder, I guess. And so, Julie, go ahead.
It's x over 6 minus x over 2.
Sorry. 1 second. Again, every class I have to do this. It's so annoying. Sorry. I have to orient the board so that it writes where I want it to write. So strange. Anyway, sign in. I'll just call out names about halfway through or something. So this is question number 5 from what's called section 2.1, but then it's 1.1 online text. It is one version of it that we're going to do here is x over
6 minus x over 2 equals 4.
Okay, great. So now, the key technique in this problem is to get rid of fractions at all costs. Like I do. I don't like dealing with fractions at all. I hate them. And so if I could do something that would get rid of the fractions in one step, that would be ideal. Okay? You could put these 2 fractions on the left together, but I just want to get rid of all fractions. And you can do that by multiplying the entire equation by the common denominator. So between 2 and 6, the common denominator is 6. So don't forget about the right-hand side. Take the whole equation times 6, and then you're back to a simple equation from what we had at the beginning of this particular section. So the technique is to multiply by the common denominator. Multiply the entire equation. Right? As long as you do the same thing to the left and right, you should be in good shape for an equation. And so, I have to write slow or else it won't. Okay, so I'm going to multiply everything by 6. Okay, let's do it piece by piece. What is 6 times x over 6? Yes, just x, right? So this guy times here is an x. What about 6 times a negative x over 2?
Negative 3x.
This 2 turns the 6 into a 3, and you get negative 3x. Okay, and 6 times 4, 24. And that's so much easier. Like if they would have gave you this, you wouldn't have had any trouble at all at the beginning. With one step you can get. Multiply by the common denominator. I like to call it that, or clear out the fractions. It's another name for it. But this gives you more detail about what you're actually doing. I just don't like dealing with fractions. I know you could have done it a different way. This is just one technique, but man, we need the answer right away.
I know they show you how to watch this, but they didn't really explain, because you know how they show you the different problem.
So they'll be having a different
multiply
kind.
everything by 10, but they didn't say this is the common denominator. So it's like, I tried rolling the problem by 10.
No, that's not gonna work for yours. Yeah. So they probably had 2 and 5 for theirs, so 10 would be their common denominator.
Yeah, it was 5 minus 2.
What? Sorry. Whoa. No. What happened? Did it shut down on me? No, it's still up. I don't know what's up. Oh man. I thought I had a lot of battery power. Oh man. Oh, it's back? Okay, that's so weird. Why would it do that? Yeah, it was so fast though. I was still writing. Oh well. I did have that happen one time. It shut down, and back to like day 1 using that whiteboard. I hate that. Yeah, so negative 2x is 24. Divide by the negative 2 to get that x is negative 12. Okay, no problem. More questions, please. You might try any other ones, give you trouble. Your assignment for the weekend is to, okay, I noticed about 29 of you are on. For those of you who aren't on, you get on. And then once you're on, I like you to try some problems over the weekend. And I like the first 10 to 15 minutes to be you asking questions. I like to do 2 or 3, maybe 4, however many you get done in that first 10 to 15 minutes of every class, so that you can get help with these things. So get started on it, get on and get started on it. I only wrote one error here, but officially what we're doing is distributing across all 3 parts. Okay, good. So, oh, you have a question? Great.
Yeah.
No, go ahead.
Okay. Mine was like 5 equals 4 plus 4 over z plus 6 or something. And
Okay, do you have a number on that?
I think it's number 8.
Okay, same section?
Yeah.
Okay. Number 8 from section what I call 2.1, but whoever, I don't know who really has the development textbook, so maybe I'm supposed to start to just use this other naming convention of whatever the online text is. Anyway, does anyone have the yellow text? I mean, you guys use, okay, I'll stay with the yellow and online together. So anyway, you'll see that it's very similar to the problems that are in the yellow text, but slightly different. And so number 8, your version is what?
5 equals 4 plus 4 over z plus x. I mean 6, sorry.
Ooh, we don't want 2 different variables.
6,
All
sorry.
right, good stuff. Yeah, linear, well, 1 variable, that'd be great. Okay, so 4 plus 4 over z plus 6. Yeah. Same technique. All right, I know it's only 1, right? Z plus 6. Officially, you can write those other guys as being over 1, and your common denominator is z plus 6. Multiply everything by it. Same technique. Clear out those fractions. You don't want it. You don't have to deal with that. A little more involved in the last problem, but we're going to multiply the entire equation by the common denominator, which is z plus 6. Okay. So we'll just write it out. 5 times that z plus 6 is equal to 4 times that z plus 6. Here's where it gets interesting, but hopefully it's pretty straightforward. This last one, the z plus 6's cancel out. So it's plus 4. Okay. Not as as close to being done as the last problem. It's still not that bad though now, if the fractions are going. What would you do next? Distribute through the multiplication. 5 times z plus 6 will be 5z plus 30. Don't forget to multiply by that other guy. Don't call it 5z plus 6. It's tempting. That's where the mistakes are going to come in. 5z plus 30. 4z plus 24. And don't forget about this other 4. And now it's getting closer to being done. Go ahead and call these guys together, 28. Okay. Shift these 4 z's over to the other side by taking them away. That's convenient because you'll just have z at that point. We got this 30 over here, which will shift over to the other side. We get z as a negative 2 once we subtract 30 from both sides. And this one is not that bad to check because z only appears once here, and so yeah, we'll work it out. Check it out. You'll see that you get the right answer. You check your work really quickly. 5 is equal to 4 plus 4 over negative 2 plus. You need this guy to be a 1, and it is. Good question. That's number 8 from the same section. Yeah.
What do you just do for that one, instead of having that, like, multiplying both by 4?
I like this. I like what you're about to say. I like what you're about to say. Let me just alternatively, go ahead.
Take the first 4 left alone and minus it from 5, so you don't have to deal with, like, the 13.6 and 4, you just have to 1 and
Okay.
actually 2 numbers.
So I led you that way just because we had just done one that way. It did cause us some trouble after the second step. But when you can, you want to combine stuff that looks alike. See, in our first problem, there's nothing really looked alike. So there really was no combining we could have done. But in this second problem, though, we definitely let's go ahead and shift this guy over here first. Take away 4 from both sides right now. And then you have 1 equals 4 over z plus 6. And you're only a few steps away from being done. Not that we have to do every problem twice, but I want you to see these other ways to do it. You don't have to do it the way I say do it up here. How do you proceed from here, though? If you had done it this way. Yeah.
You could just multiply both sides by z plus 6.
Right, same kind of technique. If you want to think about it, in this case, you might call it cross multiplying. Still same thing, multiply by the common denominator in this particular case here. Multiply both sides by z plus 6, canceling from here, leaving you with a 4. But on the other side, leaving you with z plus 6. So it's less sweat. This way it looks better, on paper. It seems to be less work. And you never know which way is going to lead you ahead of time to the easier kind of less work way. So just try what comes first to you. Don't always think that have to do it the way I say. Subtract 6 from both sides, and you end up with the same answer. Thanks a lot. Okay. Time for one more. Yep. Sounds good. Let's go ahead and move on then. So we are up to the very last section in review. We are up to, quadratic equations. Oh no, there's 2, but these 2 can actually be put together. I don't know why they're actually separate sections. Solving a quadratic equation and the quadratic formula. These 2, we're going to put these 2 together, cover them today. Whatever we don't get to, we'll finish on Tuesday. Let's take a look at our do we have sort of our syllabus? Where's that at? It looks like we're on schedule. Where's that syllabus at? Amazingly, we didn't fall too far behind. We are on schedule to do what? To take our quiz when? A week from today. If it's what I want, is it? Is that what the syllabus says?
Yeah.
September 15th. A week. Oh, geez. A week. Stop. A week from today. Thursday, September 15th. But even then, you can come and ask questions at the beginning because you won't need the whole, the whole time to take it. But it'll be not as lengthy as an exam, not as many questions, but each section will be covered in some kind of a way. So today we'll move on then to solve. That was basically solving linear equations where the variable is to the first power, and now we're going to look at solving quadratic equations where we have squares, R2.3 in the yellow text. And then an alternative way to do it, R2.4 in the yellow text. Okay, good. So these are all homework. Let me add another page here. All right, so some notes briefly and then a bunch of examples basically. So now we're going to move, put these two together, call it R. Call it R2.3 and 2.4, and basically we'll call it solving quadratic equations. Okay. And the thing is that there'll be more than one way to do it. And so what we like in the hierarchy of how we want to try to solve it, the first way we like to be able to do it is using what we did back in section R1.6, just like factoring. If we could get our factoring skills up to par, then we can solve these guys. If they are even factorable, if we could factor them at all, that would be the ideal way because we get to the answer rather quickly. When that fails, or when maybe your factoring skills aren't where they need to be, there are other ways. Okay? So, the book doesn't talk too much about the second way, but I'm going to do my best to try to convince you that the second way is better than the third. So the second way will be by what's called completing the square. And then the third way is by the quadratic formula. This is kind of your fail-safe. This is the way that will always work. You don't have to worry about when it works and when it doesn't work. But it's really bad to plug in that formula, but we'll do the best. We'll go over it the best we can to review it. These are three different techniques on how we're going to try to solve these problems. Okay, factoring from section R1.6. This might be new, completing the square, or maybe you've seen it but don't remember it, and then I'm sure at some point someone tried to beat some formula into your head. And we'll try to see how well you have that formula memorized once we get there. Let's start off with the easier way, by factoring. It's really the same questions from 1.6, now with equals 0. And that's really all it is. So if we go back to those kinds of questions, if we take something like x squared minus 5x minus 14 now equals 0. Before they were just expressions, just the the left-hand side of this. Now we have an equation equals to something. And there's different ways, but there's to start this. The standard way that we want this to be in, though, is set equal to 0. Something in front of x squared, maybe something or not in front of x, and then a constant term. We want to always have it, if we can, set equal to 0 to begin with. Maybe it's already done like that, but we'd like to get there if it's not. Okay, so you guys already have factored what two numbers multiply to give you a negative 14, but are 5 apart from each other. So we say yes, 2 and 7. Who gets what sign? Well, since it's a negative 5, the bigger ones you get the negative, which is negative 7. So now you have it factored, but this is one of the more simple ones to factor, right? Start off with the simple one, then we get those harder ones that might require you to use that factor square root. Anyway, x minus 7, x plus 2. That's not the answer though. Right? So what do we do? Just because you see a negative 7 and 2 doesn't mean the answers are a negative 7 and 2. Here's what's working behind the scenes before I ask what we do. I have 2 terms multiplied to give me 0. The only way that's going to work out is if one of them is 0. You can't have that working out any other way. So either, this means to you, either A is 0 or B is 0. Same kind of thing. Either x minus 7 is 0 or x plus 2 is 0. So it's kind of weird. You're going to be actually, looks like in this particular setup, taking the opposite signs. Because when you go to shift those guys over to the other side, you have to do the opposite operation. Yes?
What's the M and with
Oh, this thing here, I sort of make this up into a riddle for you to solve, but if you don't go through this to factor, that's perfectly fine. If you keep trial and error, that works out well. I make it to I need to find 2 numbers that multiply to be the constant term and add to be the middle term. And I set it up as a riddle when I do it. You don't have to do it that way. That's just it seems to work well. Whenever they're multiplying to be a negative, a better way to say this part is that that's how far apart the numbers are. So I always sort of exchange this thing for how far apart they are. And if I don't have too many factors, that makes it easier for me to figure out what my 2 numbers are. But it could be quite difficult the more factors that you get. So I set it as a riddle, then either one, call it M and call the other guy N. And the goal is to get these 2 numbers, M and N, that will go into the formula as the things that are in there with the X. So X is either 7 or X is negative 2. One or the other. Has to be true. X can't be anything else for this equation to be true. There's something going on geometry behind the scenes, like there's a picture going on, there's a graph. This thing is a function, x squared minus 5x minus 14. We'll wait till chapter 2 to really look at parabolas, but this thing represents a parabola. And whenever you take a function and set it equal to 0, you're trying to find out where that function hits the x-axis, where the graph of that function hit the x-axis. And so these 2 numbers that we have here are the roots. They're the zeros of the function. When you go to draw this parabola, the graph of this parabola, you got to make sure you go through 7 on the x-axis, but also through negative 2 on the x-axis. Not that this is part of this section, but it's coming. So x equals 7 and x equals negative 2. You have to make sure that you go through those, and later we'll study that. Of course, since we do have a parabola, we have a choice. Does this parabola open up or does this parabola open down? We'll see later on that because of the highest term having a positive coefficient, that means it's going to open up. And so that's going to look something, just a sketch. You don't have to be exact. We'll say the graph of this function looks something like this. Later on, in chapter 2, we'll be interested in this bottom point. It's called the vertex. We'll be 3x cubed plus 7x squared minus 20x. Or maybe, let's say, yeah, we'll say equals 0. Just know that I can make this problem look a different way by shifting something over to the other side. But you just know that you need to start with it set equal to 0. Sometimes when it's done like that, you get confused. Let me show you just really quickly. If I take this problem that we just did and just change it just a little bit on you, it's easy to get confused. X squared minus 5x equals 14. Say it started like that. The first thing people do sometimes that make a mistake with this is they start to try to factor the left-hand side and not have it set equal to 0 first. So they try this out. They say, well, this looks like x times the quantity x minus 5. This is what I don't want you to do. Don't do this. Don't do this. It's tempting to do this. Because, okay, you try to apply that 0 rule at this point. It's very special with 0. See, there's infinitely many things that I can multiply together to get 14. 7, 2, 2 and 7, a half, and 28. But with 0, one of them has to be 0. So you can't then take this and try to say that x is 14, or that x minus 5 is 14. Don't do this. I see every time I give an exam, I see students that try this, and I don't want you to fall into that trap. Make sure it's set equal to 0 first. Don't do this. Don't do x equals 14, x minus 5 equals 14. Okay? Set equal to 0 first. This doesn't work out. Don't do this. This is wrong. And it became wrong right at this step. The first step wasn't wrong. That's algebraically okay. It's that second step that's wrong. It's a 0 problem. It's a 0 thing. It's not a 14 thing. It doesn't work for any random number. It only works for 0. Right? So when I grade these exams, I'm not going to see any of this, right? Promise? All right, I'm going to tell extra points if I see it's like a pet peeve kind of thing. All right? Sounds good. Yes?
On the homework they asked, like, because I went like and looked at homework that's like the section, is this like the standard form? Like equal to 0, because a lot of it asks like,
Standard form.
so like it says like answer the question, standard form, but if we actually answer the question if equal to 0, and there's the answer.
Standard form. Yes, set equal to 0.
Okay.
So just remember that you have to set it equal to 0 first. Let's go back to that question. Anyway, what's that? Down here somewhere? Spin the page. Okay, good. The first thing that should alarm you about this is that you see an x cubed. That should be alarming. It should be a problem. But there's a quick way out of the problem, though. We factor quadratics. You know, I said this was quadratic equation, right? This is a cubic. This isn't quadratic. But we use something to quickly get it into a quadratic. All right.
Take out a greatest common factor for just dx.
Yeah, if it didn't have like if there was a constant term, we'd be in trouble. Like, actually, I don't want you to have to be able to factor cubics, not yet. It's very difficult to factor a cubic. We'll get techniques to learn. We'll learn techniques. I forgot the section. I think somewhere in chapter 2. We'll learn how to factor cubics in 4th degrees. But for now, any kind of cubic or 4th degree, there must be something to bail you out to get it down to a quadratic. Okay. And so factor out what they have in common, the greatest common factor, and in this case, conveniently, it is an x, which gets you down to a quadratic. Take the x out, you'll have 3x squared, plus 7x minus 20. The key is not to forget about that x that you took out at first. Yes, you should focus on the quadratic in x, but that x is spit out, that's also going to be part of the solution. Instead of having two things, you'll get your three things. You'll get these two guys once you figure out what they are, but you'll still have that guy out there. You'll have three of them. I made it quickly. I hope this is factorable. Tell me that it is, please. No.
It's going to be 7 apart, right?
The 3 is involved this time, so it's not the standard. We don't have to go into the factor square, but I can go if you want me to. Nah, there's enough of that factor square. Come on, man. Yeah, only think about going factor square when there's something other than 1 in front of x squared. Because it's not the same setup. There's a 3 that gets involved that screws up the whole setup. So it's 3x and x, definitely. That's the only way to break apart 3x squared. So if it is factorable, it has to break apart like that. Good thing about 20 is there's not too many options for you. We could use 1 and 20, we can use 2 and 10, or we could use 4 and 5. So when we have options, try the ones that are closest together first. And I think if I set it up right, 4 and 5 work. Where does the 4 go? Where's the 5 go?
5 goes with 3x.
Very good. The 5 goes with the 3x, and the 4 goes with the x. Why? You want to end up with a 7. You want these guys, after multiplying, to be 7 apart. You see, 3 and 4 give you 12x. 3 and 4 give you 12x. 3 and 4x give you 12x. And 5 and x give you 5x. So yeah, they'll be 7 apart at that point. Who gets the negative, though? Very careful. The 5's got to get the negative because it needs to end up as a positive 7x. So the 5's going to be a negative. So we didn't use factor square, but we could have. You know what I mean? It's not an influence. I don't have anything against it. Some people don't like it. Do whatever it takes. This was trial and error, but smart trial and error. We got to the answer rather quickly. There weren't that many options. I like going to the factor square when there's way too many options for me to try to consider. Yes?
I lost you. I don't know why you started doing 1, 20, 2, 10, 5.
Okay. Factors of 20. I'm going to put 2 numbers in here that have to multiply to 20.
Why did you do that?
It's all about multiplying out. When you go F-O-I-L, it's the L last that'll give you the constant term. The number that's in there with the 3x and the number that's in there with the x, whatever I decide to put there, when it comes to FOIL, the very last step is those 2 guys times each other. It has to be what the L is, and the L is your constant term when it's set up to be in standard kind of quadratic form. So my constant term is a 20. In fact, more specifically, it's a negative 20. So when I started listing these factors, I have to think of something that goes in a black square, something that goes in a red square, that'll give me 20. So immediately I went to factors of 20. If this whole thing doesn't work for you, go with the fail-safe of the factors group. Once you get used to it enough, it'll be your default. Because there's too much thinking maybe behind the scenes here.
I have a question.
Yeah.
Isn't the 3 only 4 times this n to the 7n?
It's not. That's what it means. He said, well, wait a minute. I'm not going to get them to be 7 apart by themselves. They're only 1 apart. But the key is that there's a 3 that's sneaky. It's involved in the process. This isn't just a 4 times x. It's a 4 times a 3x. Whatever's going in the red spot isn't going to be by itself. It's going to be times 3. So if officially we want to write it up in riddle form, the riddle form is I need 2 numbers that give me negative 20, but when I go to add them, one of them is going to get a 3 multiplied by it. It isn't m plus n, it's 3m plus n, or and that's supposed to be equal to the positive 7. That's the key when you want to, when you have something other than 1 in front of x squared. But if you want to, just default to the factor
It's
square.
always up, put the number down there, and how you, so we
Sure.
should.
Yeah, if you don't want to do that factor square, put that number down there and just basically try these options. There's not too many options there for you to put m and n. There's only 3 options. If you get them wrong, try to flip them around. So if you try 5 and 4, 3 times 5 is 15, but 4, no, that's not going to work out. They are going to be 7 apart from each other. But when you flip it around, 3 times 4 is 12, and 12 and 5 are 7 apart from each other. It's going to work out. Okay? That's the talking, intuitive, making your way through it, maybe trial and error, but smart trial and error. If you don't like that, go to the default factor square. It'll get you through. If it's factorable at all, it'll get you through. Yes?
If you did the factor square, would you multiply with the negative term?
So take it aside. Squared, negative 20. Multiply them together.
So the
Negative 60. Now I can blindly think about them adding to 7, being 7 apart from each other though, because why are they apart? Why are they not adding up? Is because that's a negative that they are apart from each other. So I need multiples of 60. Not too easy to deal with 60, but try your best. They need to be 7 apart from each other. 6 and 10 are too close. Work your way out from 6 and 10. And you'll see it's 5 and 12. So you don't have to list every factor, you have to list them smartly. And you put your 5x, you put your 12x, but wait a minute, you need that to be a positive 7. One of those needs to be a negative. It isn't 5 and 12. Yes, it is 5 and 12, but one of them has to get a negative. This time, it's going to be the smaller one negative than negative, because in the end, you have to end up with a positive 7. So it's not 12 and 5, it's 12 and negative 5. Factor, 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 factor. Put it all together and do that. What does 3x squared and 12x have in common? 3 and x. What does negative 5x and negative 20 have in common? Negative 5. Take out the negative, they're both negative. What does 3x squared and negative 5x have in common? Don't think of nothing. Usually they have at least an x in common. And when they don't have anything in common, say this was say at that point you had a 3x and a 5 or something like that. If you're at this point, if they don't have anything in common, just don't put a 0 there though. Officially, they always have something in common. Everything has a factor called, there's some number that's a factor of every number. 1. So at least, when it looks like they have nothing, it doesn't have anything to do with this problem, I'm sorry. But just so you know, when it looks like they have nothing in common, at least they have a 5 or 1 in common. So you'll always at least have a 1 in common. That's an aside. That's not part of this problem. But anyway, here they share a 4. So you're done. 3x minus 5x plus 1. Okay, we're not done. We will have the answer. In the end, we're looking for answers here. We need answers. We need x equals, then we're done. If you stop here on an exam or a 5-point question, I'll give you 4. You have everything, but you're missing something. In the end, we want to know the values of x that solve the equation. So we're going to need to know what x is. We're going to need to do the same thing. Take these separately and set them equal to 0. But go back to our problem, which is where, what's that? The bottom of this thing? There it is. Okay, I extend the page. Okay, technically we have here now equal to 0. And they're not just these two things. Yes, 3x minus 5 could be 0. Yes, x plus 4 could could be 0. There's a third answer out there that x could be 0. That's the one people will forget about. I think they factored out in the very beginning. 5/3. Add the 5, divide by the 3. -4. Take away the 4. And 0. Three different answers. Okay, well that's because we can factor it. The question is then, what happens when you can't factor it? When factoring breaks down. There's still other kinds of factoring. Remember, we did the standard factoring. Remember, there was a special factoring too, right? The difference of squares, the difference of cubes, the sum of cubes. That can play a role too. There's special factoring. It's not coming up right now, though, but right now this is the standard kind of factoring. But it could be. I mean, it could. Nothing to stop it from coming up. All right. 6x squared equals 54. Now with this one, when there's no x term, you can actually go and try to, you can get rid of this 6 in front. There's two ways that you can attack this problem. You can do the conventional always set it equal to 0 way. 6x squared minus 54 equals 0. You do that. Or you could go with just taking as it is and dividing by 6. But you have to be careful with that second way, though. In that second way, you're looking at x squared equals 9. Don't be short-sighted and say that the answer is 3, and you're done. All right, what do you square to get 9? It's 3. 3 is what you square to get 9. You're done. But you're not done. There's another phantom answer there that you wouldn't think of, doing it this way. Negative. So what we're officially doing here is undoing the square by taking the square root. But we have to take plus or minus the square root. So we get plus or minus 3. It's an extra step that we have to think of, that if we do it this way, we don't have to think of that way. Only do this non-equal to 0 thing if the x term is missing. Don't try this if it was one of those other kind. We saw what happens when you try that. Okay. If you try it the other way and factor out the 6, you're less likely to forget about the other answer. How does x squared minus 9 factor? It factors as x plus 3 and x minus 3. So it would be more obviously that those are your two answers. So do it however you want. I showed you two ways. There's this other way that you could do. It requires you not to forget about plus or minus. Here, there's no even worrying about it. X is equal to negative 3 or x is equal to 3. What about 6? I have 3 things multiply, right? Just like last time. But that's a false statement. 6 can't be 0. If you want to set it up that way. So it's not going to be that thing. What made it true last time is that there was a variable that we had pulled out. If there's a number you pull out, that's not going to be part of the things that make it 0. But 6 isn't the 0. It's coming from these two guys that give you the 0. Questions about that? All right. So what happens when factoring fails? When you can't factor, maybe everything isn't factorable. There's some quite likely claim that you will not be able to factor, no matter how good your factoring skills are. So then what do you do? We're going to go with method 2. I will show you method 2. This might be new for some of you. You might not like this new thing because you've never seen it before. You don't want to try it. You don't want to try anything new. I understand that. You don't have to. I want to show it to you. I will not force you to do it one way or the other. I won't say you have to do this by this way. Okay? It's called completing the square. I'm hoping to convince you to eventually get you around to where you like this way. Okay? I'd rather this way actually than that quadratic formula. You see, I have a bias. Completing the square. It does get bad. There's some possibilities where this is a mess, but let's see when it's first not that bad. Completing the square. What does that mean? If you have x plus 2 quantity squared equals, for it not to be factorable, I cannot pick a perfect square. So give me any number that is, it has to be a positive number, right? How can you square something and get a negative? So any positive number that's not a perfect square out of 11. Okay, we're going to get to this. The problem doesn't start like this. Okay, this is midway through. Okay, our goal is to get the left-hand side to be what's called a perfect square, of something that is squared, so that we are 2 steps away from getting this answer. Just like with this problem, where we we're kind of at this place. It's not an x squared though. It's x plus something squared. So what though? Take the square root of both sides. Don't forget plus or minus. Okay. So take the square root of both sides and have it as x plus 2 is plus or minus square root of 11. You don't have to know what square root of 11 is. Don't be scared by that. So what? It's okay. Leave it like that. Square root of 11. What are you trying to do? You trying to get what x is? Just get rid of the 2. Subtract 2 from both sides. You're done. X equals negative 2 plus or minus root 11. So if you can get it to this form, a couple steps and you're done. The key is, sometimes the difficult part, is getting it into that form. The completing of the square. Here, the square is already completed. So there's some steps above this that I want you to work your way through. Okay? We'll be able to figure out the steps. Okay, now we'll be able to, this is an example of square already completed. I won't be able to decompose this and figure out what it is. I might be able to. Let me try. So x squared plus 4x minus 7 equals to 0. That's what this guy starts out as. Here's the square already completed. Okay. This problem will start out looking like this. You can't factor. You can't take 2 numbers that multiply to give you 7 that are 4 apart from each other. You're not going to be able to factor that. So you need something else. I need this to be a perfect square on one side. So here's the steps. Here's the algebraic steps that you do to make it a perfect square. First thing is, you need to, whatever that constant term is, shift it over to the other side. So take the 7. I know we said make equal 0. Here's what we're going to do. We're going to make x squared plus 4x. We are going to add something to both sides. It's an equation. We're going to add something to both sides. Shift this 7 out of here first. Add the 7. So it's a 7 over here. add something to both sides so that this polynomial on the left is a perfect square. Please stop texting this. It's distracting. Well, you and alright. See, perfect square meaning that if we multiply this guy out, this is how I did it in my head. I said x squared. How does this work? How does this work? X plus 2 quantity squared. What is that when we multiply it out? X plus 2 times x plus 2. What is that? It's x squared. What's the middle term? There's a 2x and a 2x, so it's a 4x. And the last term, L, we get a 4. So what's so special about, oh, I shouldn't use these numbers. There's a special connection between, yeah, that's not a good choice. There's a special connection between these three numbers. The number that's in there with the x, the number that's here in front of the x, the number that's here as the constant. This is a bad choice for our first example, but basically we need to just exploit this connection that these numbers have. Okay? It's unfortunate though that half and square. Okay, I'll pick a different example. But anyway, the connection here is that it'll always be, just think about how it works out. You know, this guy, he's always double whatever he is. Or she. You know, this term here is double whatever this term is. The connection between the number in front of x and the number in there with the x in the square is that the one that's here is double whatever that one is. Flip that around, this one is always half of whatever that one is. By the way, it's going to work out. And then how's the connection here? It's unfortunate I chose this as an example, but this guy is always the square of this guy. I should have chosen something else. X plus 3 equals the square. It's easier to see. We get x squared plus 6x plus 9. The connection is between these three numbers is that if I know what this guy is, I can just take half to get that. And then I square to get this. That's what we're going to do. I need to know what's going to be in there with the x. Whatever sign that is, I take that with me. The connection is that coefficient that's in front of x, I take half of it to get what goes in there with the x. Half of 4 is 2. I take this number and I take half of it to get the 2. Don't forget this thing is squared. What's the connection here? Once I have this number that's in there with the square, I square it to get that number that I need to add to both sides. So half and square. Half of the coefficient on x goes in there with there. Square that. That's what the blank. Sorry, that's what you have to add to both sides. I have to add 4 to both sides. Whatever I do left, I have to do to the right. Sorry, Mark. This is such a bad example. It's terrible of me. Because half and square, they're all the same with 2s and 4s. This is so much a better example. I wish I would have started with this one. Sorry. I didn't have that foresight ahead of time. That's poor planning right there. Sorry. Questions? Is that a hand up? Yes.
What is that 2 actually be?
This 2 here is the, oh, sorry. I didn't make sure that a different number. I mean a different color. I'm trying to complete the square. I'm trying to make this a perfect square. Now this is a square. The square is completed.
But half in the full formula in the other example,
Is this 2 that's here that I'm writing up in that spot?
So, like in that big formula right there, the number in the middle is 6, and half of 6 is 3. Whereas in that big formula there, the number is 4.
Yeah, it's my fault. That's
Would
poor,
it-
that's
would it
poor
be
planning
even?
on my part. Can we just forget about that example and go with something like this? Okay, so what's it going to be when you multiply it all out? It's going to be an x squared and a 10x and a 25. So you're gonna be looking at this much of it. You're gonna get that much of it, and your goal is to try to figure out what this needs to be so that when you put it all together, it is a square. And so the game is take this coefficient, take half of it, wherever you get there, square. Totally forget about that first example, because 4s and 2s, they really obscure.
I wasn't looking at the 4s and 2s, I was looking at the 3s and 6s.
Yeah, this is it. These two together are good examples.
Yeah, what I'm confused about is if you take that in relation to the one in the middle, the x plus.
There's 2s and 4s there. Forget about that.
Okay, so, all right.
Start a new problem? Yeah, that's so bad. I'm sorry about that. That's such a bad. Anyway, just to finish it off, I won't do another one. Just to finish it off, equals to 11. And you're at this point now. Square is completed. You're equals to 11. Now you finish it off. All right, let me work these backwards, though. Let me do these now. That's such a bad thing. I'm so sorry. I feel terrible about that. X squared plus 6x. Where? 30? Yeah, 30. 30 minus 30. 30. 30, yeah, no, that's 30. Equals 30. Say that. This thing that's in the box, this is what you have. If you don't have it, if this thing is on the other side, you always start off by shipping that constant over to the other side. And so here we are. We already have that case. And so I'm looking at what's in the box. I have this box here. I would like to add something to both sides. I would like to add something to both sides. That something is the answer to this riddle. It's a 9. How can I make this into a perfect square? There's no way that's going to be a perfect square unless it is x plus root half of the 6, 3. And in the blank space, what's the number? What's the constant? The constant is the square of that. We take half and we square. So it is a 9 that we have to add to both sides. Add a 9, add a 9. Question?
Is a constant always going to be a perfect square?
Yeah, because you get to it by squaring. It might not look nice, but yeah, you get to it by squaring. It might be a fraction, but it should always be a perfect square because the way you get to it is by squaring whatever goes in there with the x. The process is to take half and square. So it will guarantee to be a perfect square, this thing that goes in the blank space. If you don't have a perfect square here, then you've done something wrong. It might not be an obvious perfect square, but it definitely should be a perfect square if you're squaring. You get that number. 9, 25, 4. There is a pattern here. These numbers are squares. Okay? So to finish the problem out, it starts off like this. You can't factor it. So you get the x terms by themselves, shift the constant term over. What's helpful, doesn't have to always be the case, but if this is an even number, it makes things easier. Everything's in terms of just integers at that point. Half of 6 is 3. 3 squared is 9. So I add 9 to both sides with the goal in mind of having the left-hand side be a perfect square. So I can just do a couple steps and be done. My goal is to get to this point, so I can do a couple steps and be done. What's my couple steps? Take the square root, get rid of the number that's in there with the x. Take the square root, here take away 2. Now for our example, it's take the square root and take away 3. Take the square root, take the square root. It's meant to be that this guy isn't a perfect square. If this was a perfect square, that's a clue that you should have been able to factor it. Not on purpose. I used to make mistakes on purpose, now they just happen. Just find a mistake, just let me know. Okay, still not on purpose, very good. So then we take the square root, and we get x plus 3, not equals to root 39, plus or minus root 39. I don't think we're going to do too good of a job of convincing you that this way works better. And I'm doing my best. I'm failing in my job. It's all good. So we're watching football, You're just take away 3 and be done?
Yes.
Take away 3, and the answer is x equals negative 3 plus or minus root 39. Done.
That's how you want to make that.
Quadratic formula for next class. Have a good weekend. I'll see you guys on what's that? Tuesday.